Hey guys! Alright, today we're going to do Chapter 8, Section 2, which is limits of sequences. So this is probably the first time that you guys have seen limits, so I wanted to take it really slow, and you guys are probably going to get really annoyed, but at least this is a video so you can fast forward through all my slow talk. Okay, but I really just want to make sure that you guys understand what it means to have a limit. Okay, a limit is not an equation, okay, it's not something that it's actually equal to, it is just an idea of something that you are approaching. Okay, so limits don't mean that at the end of your sequence or whatever you get a specific number, they mean that you're approaching a number. Okay, so first of all, let's talk about infinity. Infinity is a very special idea. We know we can't reach it, but we can still try to work out the value of functions that have infinity in them. Okay, so infinity is not a number. It is just an idea that we use to get across the point that numbers continue forever. Let's start with an interesting example. What is the value of 1 divided by infinity? Well, the answer lies in what I just said. Infinity is not a number, so I cannot divide by it. That's like the same thing as saying 1 divided by beauty. Okay, it doesn't make any sense. Maybe we could say that 1 divided by infinity is equal to 0, because if I split 1 into infinitely many parts, then each of those parts would be almost nothing. But that really doesn't make any sense, because if I split it into infinity parts and each part is 0, where did my 1 go? Okay? So the fact is that 1 divided by infinity is actually undefined. Okay? We can't find it. It doesn't make any sense. So instead of trying to work it out for infinity, because we can't get a sensible answer, what we can do is try larger and larger values of x to figure out what it's approaching. So here's a little table I have here in a graph. For my x values, I'm just trying 1 over 1, and then 1 over 2, 1 over 4, 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000. And you'll notice that as I'm plugging these values in, I'm getting closer and closer to the x-axis, which is 0. So what is happening as our x values are getting bigger? We are approaching a value of 0 for our x. Okay, our x is getting closer and closer to 0. So what we can do is we can write this as a limit. We can say that the limit as x approaches infinity of 1 over x is equal to 0. So I'm saying that as my x values are getting larger and larger, the value of this equation is approaching 0. Okay, let's try a problem here. Let's figure out what the limit as x approaches infinity of 2x is. Well, let me just think about that. If I am plugging in bigger and bigger values of x, so let's say I plug in a 1, I get 2. I plug in a 10, I get 20. I plug in 100, I get 200. I plug in 1,000, I get 2,000. Okay, the bigger numbers that I'm plugging in, the bigger value I get out. So this is actually going to be approaching infinity. Okay, so as my x value is approaching infinity, my 2 of x is also approaching infinity. Now, what is the limit as x approaches infinity of the function y equals 2x squared minus 5x? Well, again, I need to think about what's happening as I'm plugging in larger and larger values. So, if I plug in 1, I have 2 minus 5, okay, it's negative 3. If I plug in 10, now I have 200 minus 50, okay, that's 150. If I plug in 1,000, I'm going to get bigger and bigger, right? So, no matter what, as I'm getting bigger x values in this equation, my answer is going to get bigger and bigger, therefore, I'm going to approach infinity again. Okay, let's look at the limit as x approaches infinity of negative 3x plus 2. Basically, when you're looking at equations like this, where we've got different parts of the equation, you can think about each part of the equation, but the smaller parts don't matter. Okay, the parts that have the larger exponents, those are the parts that make the big difference. So for example, in this problem back here, the negative 5x, even though that was negative, it didn't really mean much by the time I was getting into the hundreds and thousands and 10,000s. Okay, the thing that mattered was this 2x squared because it's increasing at a much faster rate than your 5x's. So in this problem here, my negative 3x is the part in this function that matters because that's the part that's increasing faster than 2. It'd be like saying if I add 2 onto 100, if I add 2 onto 1,000,000, well, the 2 doesn't make much of a difference, does it? So all I need to worry about is this negative 3x here. So essentially, this is the same thing as saying the limit as x approaches infinity of negative 3x. And if I think about that, well, if I plug in 100, I get negative 300. If I plug in 1,000, I get negative 3,000. Okay, the bigger my numbers are, the closer and closer I get to negative infinity. So this limit is actually going to be negative infinity. Okay, now this problem down here, this is a little bit trickier. So basically, I'm going to try to portray this using a graph. I'm going to try to make you guys understand what's happening here just by using some graphs. So if I make a table, and I plug in, let's just say 0, 1, 2, 3, 4. Okay? Well, if I plug in a 0 here for my n, that would mean that I'm dividing by 0, which I can't do. So I'm going to say that that one does not exist, or it's undefined. Okay, if I plug in a 1, I've got negative 1 to the first, which is negative 1, divided by 1. So that would just give me negative 1. If I plug in a 2, negative 1 squared is positive 1, and positive 1 divided by 2 to the second, 2 squared, that would be 1 over 4. Okay, negative 1 cubed is negative 1, and 3 squared is 9, so this would be negative 1/9. Okay, this one would become positive 1/16. So you'll see that what's happening every time is that I'm going back and forth between a negative and a positive number. If I represent that graphically, okay, I start with my does not exist, my 0, I can't have that. Okay, but at 1, I've got negative 1. Okay, so there's a point there. At 2, I've got 1/4. Okay, at 3, I've got negative 1/9. At 4, I've got 1/16. Okay, so essentially what's happening here is I'm going to kind of balance out, and I'm going to be approaching my x-axis again. So it's going to be jumping back and forth every time, but I'm still approaching that x value of 0. So in this case, the limit of this function is going to be 0. And this is what I would call an alternating harmonic sequence. But we're not going to get into that too much. That's just for people who are interested in calculus. Alright, when you're looking at rational functions, you need to compare the degree of the numerator with the degree of the denominator. So again, like I was talking about earlier, the only thing that really matters is the biggest part of the function. So if you have a big numerator and a really small denominator, that denominator doesn't really matter. Okay? So if the degree of the numerator is more than the degree of the denominator, the function approaches infinity. So in other words, if my numerator is getting big and my denominator doesn't really matter, well then my overall function is going to approach infinity. It's just going to keep getting bigger. Okay, if the degree of the numerator is less than the degree of the denominator, then the function approaches 0. So if my numerator doesn't really matter and my denominator is getting bigger and bigger and bigger, well that would be something like if I had 1 over n. So let's say I had 1 over 1, 1 over 2, 1 over 3, 1 over 4. You'll notice that what's happening is as that denominator is getting larger and larger, your function is going to approach 0 because it's getting smaller and smaller towards 0. Okay, if the degree of the numerator is the same as the degree of the denominator, then you need to look at the term with the highest degree in each part and simplify. So that one's actually really easy to do, and I'll show you how to do that in a second. So this one right here is a perfect example of that situation. What is the limit of the function we've got 2x squared minus 3x plus 2 in my numerator and 4x squared minus 3 in my denominator. So you'll notice that the only part that I really care about in my numerator is this 2x squared. And the only part that I really care about in my denominator is this 4x squared. So I can actually rewrite this problem as the limit as n approaches infinity of 2x squared over 4x squared. Well, I can actually just simplify this. If I do 2x squared divided by 4x squared, that's the same thing as 1/2. So this function actually just approaches 1/2 as your n values increase. Alright, a sequence is convergent if it approaches a finite number, and a sequence is divergent if it approaches an infinite number. Okay, so these are just some vocab words. Convergent means that it approaches a number, whereas divergent, it approaches either infinity or negative infinity. Let's just go back through 1 through 5 and determine whether these were convergent or divergent. So for number 1, we approached infinity, therefore this is going to be considered divergent. For number 2, we approached infinity, so this would also be considered divergent. For number 3, we approached negative infinity, so this would be also divergent. Number 4, we approached 0, so this one would be convergent. And our last one, number 5, we approached 1/2, so this one would also be considered convergent. Alright, that is everything for section 2.